In this video, I am going to show you a tutorial on how to balance ionic equations in acidic medium. Bear in mind, this method can only be used for redox reaction. Redox reaction, if we recap what redox reaction is reaction that occurs when the species involved undergo changes in oxidation state. In oxidation state or oxidation number. Okay, if we focus in this question, I'm going to use this question in this tutorial that I have extracted from your checkpoint 4.1. In this reaction, we have to balance this reaction between dichromate ion, Cr2O7 to minus, with sulfur dioxide, which produces sulfate ion, and chromium ion 3+, chromium 3 ion. Okay, so the first step to answer this kind of question, you have to separate the equations into two parts, the oxidation part and the reduction part. We do not have to determine which one is the oxidation half reaction and the reduction half reaction in this kind of question, at least not yet. Okay, so the first one is Cr2O7 2 minus, and it will produce Cr3 plus. Okay, so the first thing that we have to do is we have to balance the atoms, okay, that is apart from oxygen or hydrogens. So in this case, we have chromium Cr2 on the left hand side, and we have chromium Cr3 plus, but we only have one of this on the right hand side. So we have to balance this. Okay, so how do we balance atoms apart from oxygens and hydrogen? We add the stoichiometric number in front of it, stoichiometric coefficient. So we have 2 on the left hand side, we have 1, so we have to multiply this by 2. Multiply by 2. Okay, so now the chromium atom is already balanced. And what we do next, we balance the oxygen atom. On the left hand side we have 7, on the right hand side we have none. So what we do is we have to add water molecules, and the amount of water molecules that we have to add depends on how many oxygens that there are. In this case, there is none on the right hand side, and we have 7 on the left hand side, which means on the right hand side it does not have enough 7 oxygens. So we have to add 7 H2O. Okay, so we have to add 7 H2O because each of the water molecule, each of these has only 1 oxygen. Okay, so now we have balanced the chromium and the hydrogen atoms. What we can do now, we can balance the hydrogens, because on the right hand side we have 14 hydrogen atoms, and on the left hand side we have none. So what we do, we add hydrogen ions on the side that has no hydrogens. So we have to add 14 hydrogen ions, or what we call as protons. So now the chromium on the left hand side and the chromium on the right hand side is already balanced. The oxygen on the left hand side and the right hand side, they are both balanced, and the hydrogens on the left hand side and the right hand side is already balanced. What we can do now, we have to balance the charges. Okay, so we have to balance the charges. So we have to calculate the charges on the left hand side and the right hand side. And on the left hand side, the chromate ions, it carries -2 charges, and there's only one of these. And the protons carries +1, and there are 14 of these. Okay. On the right hand side, the chromium carries +3 charges, and there are 2 ions. And the water, the charge is 0, and you have 7. So this brings to a total of positive 14 minus 2, +12. And on the right hand side, this carries +6 plus 0, +6. Now we have to add electrons in order to balance the charge. Where can we add the electrons? We add it on the side. We add it on the side that lacks or that has less negative charges, or we add it on the side that is more positive. If you find it difficult for you to visualize where to add, you can visualize it by drawing the number line. So on the right hand side, the charge is +6. So I'm going to put +6 right here. And on the right hand side, we have +12. +12. Okay, so in order for us to balance it, they have to have similar charges. When we add electrons on the number line, the charges will move to the left hand side. So let's say if we were to add electrons here, it will move to the left hand side. It will move to the left hand side. So we do not want to add on the positive charge, +6 charge, which is on the right hand side. If we add it on the left hand side, this one, if we add it here, we can add electrons for it to move from +12 to +6, and the amount of electrons that needs to be added is the difference between +12 and +6, which is 6. So we can add 6 electrons. So we add it on the left hand side. So we have to add the electrons on the left hand side. So we add it here. We add it there. Plus 6 electrons. So now the charge is -6, which brings a total of, +6. Okay, so now the half equation for this dichromate ions to form chromium 3+ ions is already balanced. So now we proceed with the next half equations. And in these equations, in these reactions, it is the transformation of sulfur dioxide, to produce sulfate ions. Okay, so now we have to balance the oxygen, which is apart from oxygen and hydrogens. So in this case, it is the sulfur atoms. If we look on the left hand side, we have 1 sulfur atoms, and on the right hand side we have 1 sulfur atoms. So the sulfur atoms are already balanced. So now what we can do, we have to proceed with the next step, which is to balance the oxygen atom. So on the left hand side we have 2 oxygen atoms, and on the right hand side we have 4 oxygen atoms. And in order for us to balance this, we have to add water molecules on the left hand side, because it does not have enough 2 oxygen atoms. So we add 2 water molecules. So now we have 4 oxygen atoms. We have 4 oxygen atoms. We have 4 oxygen atoms here as well. But now we have introduced the hydrogen atoms. So we have to balance the hydrogen atoms on the right hand side to produce 4 protons. By adding 4 protons on the right hand side. So now if we review, we have balanced the sulfur, we have balanced the oxygen, we have 4 on the left hand side, 4 on the right hand side, and now we have balanced the hydrogen atoms. So what we have to do now, we balance the charge on both sides. So in this side, it is 0. This one is also 0 multiplied by 2. On this side, however, we have -2. Okay, so on the right hand side, this sulfate ion, it carries -2 charge, and there's only one of this. And the protons carries +1, and there are 4 of this. Okay, so this brings a total of, on the left hand side, 0. On the right hand side, +2. So we're going to do the number line method. So +2 on the left hand side and 0 on the right hand side. So we add electrons on the left hand side, which will proceed to the right hand side. So we add 2 electrons here. So we add 2 electrons. Which will bring the charges to 0. So now the atoms are all balanced. The sulfur, there's 1 sulfur, 1 sulfur. There's 4 oxygens, 4 hydrogens, 4 hydrogens. Total charge of 0 on the left hand side, total charge of 0 on the right hand side. So what we do now, we have balanced half equations for both of the reactions, half equations. So I'm just going to copy this down. Okay. So now we have both of these as balanced half equations. We can now determine which one is the oxidation and which one is the reduction half equations. So let's have a look. On the top side of the half equations, we see the electrons on the left hand side, which means that this is the reduction half equations because the chromate gains 6 electrons. So this is the reduction. And on the bottom part, on the bottom half equations, this one is the oxidation half equation because it released 2 electrons. This is the oxidation. Okay, so now because this is a redox reaction, it occurs together, we have to make sure that the electrons released by the oxidation half reaction will be the same as the electrons needed for the reduction half part of the equation. Okay, so which means that we have to make sure that the electrons on this is the same as this here. So what we can do, we can find the common lowest common multiple. So in this case, between 2 and 6 will be 6. So we have to multiply this whole thing. We have to multiply it by 3 to get 6. We multiply this whole thing by 3. And this will produce 3SO2 plus 6H2O, and this will produce 3SO4 2 minus plus 3 times 4 12 protons plus 6 electrons. So now the electrons released here is the same as the electrons in this half equations. So I'm just going to copy this down, paste it here. Sorry. Okay. So make it a little bit smaller. Okay. So now we are left with balanced half equations, the fully balanced half equations. So what we can do now, we can combine both of these equations together between this and this. Okay, so let's have a look. All of the common terms can be added together. And all of the common terms that appears on different sides can be subtracted. So on the left hand side, okay, so now we can combine these equations together. So remember, the common terms on the same side can be added together. They can be added together, and the common terms on different sides, like these hydrogens, they can be subtracted from each other. So first we see the common terms electrons appears on the left hand side and on the right hand side. So we can cancel them out because it's 6 minus 6. 6 minus 6. Okay, now if we look on the right hand side, we have 7H2O, and on the left hand side we have 6H2O. So cancel out. This one, when we cancel, it has 7. This one has 6. So the one with 7 has one more water more than the 6H2O. So this will be left with 6H2O. 1H2O. One H2O. Okay, and then the protons, here we have 12, here we have 14, so this has 2 more than this, so we can cancel this out. This will be left with 2 protons, and now everything else, they are not common terms, they are not the same, so we just bring them down. So here 3SO2 plus Cr2O7 2 minus plus 2H plus, and we will form 3SO4 2 minus plus 2Cr3 plus H2O. Okay, so now what we can do now, before we end this, we have to check whether it's properly balanced. Just to make sure you can do this analysis on your own, we do the left hand side, right hand side analysis. So the left hand side, right hand side analysis. Okay, so we do this by counting the atoms on both sides and counting the charges on both sides as well. So on the left hand side, we have sulfur, we have oxygen, we have chromium, we have hydrogens. And on the right hand side we have the same types of atoms. So on the left hand side we have three sulfurs, 3 sulfur here, and we have 3 sulfur on the right hand side. Okay. The oxygens on the left hand side, we have 3 multiplied by 2, 6. 6 plus 7 equals to 13. So we have 13 oxygens on the left hand side. And on the right hand side, we have 3 multiplied by 4, 12, plus 1, 13 as well. 13. And on the left hand side, we have 2 chromiums. 2 chromium. And on the right hand side, we have 2 chromiums. 2 chromiums. And the hydrogens on the left hand side, we have 2, as we can see here. 2 hydrogens. And on the right hand side, we have 2 hydrogens as well. So now if we look, the atoms are all balanced. Now what we want to do is we want to balance the charges. So to balance the charges, okay, so here this is 0. This is 0 equals to 0 plus -2. This is -2. -2 plus +2 here plus +2. So it will be a total of 0. And on the right hand side it should be 0 as well if it is balanced. So here we have 3 times by -2, 3 -2 plus 2 times by +3, 2 times by +3 plus the charge of water molecule, which is 0. 0. So this is also equals to 0. So now if we look at the left hand side, right hand side analysis, the atoms are all balanced and the charges are balanced as well, which means that this is the final balanced equations. And remember, it is very important for us to show both of these as well as this. So this is important to be shown. Same as this one as well, important to be shown. Okay, so if you have any questions regarding this, kindly leave a comment on my YouTube video, on my YouTube channel, or you can also post it online on my Google Classroom. Thank you very much.